Hi, welcome to this lesson in developing spatial thinking. Today we're going to be going over isometric drawings, which are some of the simpler drawings that you'll do, but they're also the base case and they're very important to learn because you'll often go from projection to projection using isometric drawings. So let's jump into what isometric drawings are. Isometric drawings are drawn on isometric graph paper, and isometric graph paper is composed of these tiny triangles as opposed to the normal squares that you'll see on normal graph paper. What this allows you to do is to draw an object almost with a 3D frame of mind, which is exactly what isometric drawings are. They are a 2D representation of a three-dimensional object. So isometric drawings are drawn as if you were viewing the object at a diagonal. They're also viewed as if you were looking above the object, or if you were above the object looking down on it. You'll also notice that in the example on the right, we only have kind of the wireframe of the object. We don't actually have any indication of the back of the object. We don't indicate the walls. It's just based off of the edges of the object. And it'll be important to consider that we can't see the back of the object. That will come in handy later. So let's look at a few examples. You can see here we've got a small selection of isometric drawings which kind of vary from depth and height. You can see in the bottom a flat X there and an L there, but then you can also see in the upper middle, you can see a small square that has a piece taken out of it, what looks like a staircase off to the right there. So like I said, these are all very basic projections that you'll see quite often as you go from drawing to drawing. And it'll be important to gain an intuition for isometric drawings that when you look at one, you can immediately imagine what that object looks like in real life. So we'll continue on with our notes for isometric drawings. Like I mentioned earlier, it's important to consider the fact that you can't actually see all of the object. You'll notice in the object on the right that it's actually a relatively high-walled object, and that leaves some ambiguity on what's behind that wall. It's possible that there may be a 2 or 3 cube combination behind that wall, but because we can't see that in the isometric drawing, we can't be entirely sure. Now, if we viewed this object from a different angle, we could probably see what's behind that wall, but it's an important consideration to make that when you're going from an isometric drawing to a coded plan or to an orthographic projection, which are things that we'll talk about later, you want to make sure that you're taking into account the fact that you're not seeing all of the object if you only have one view of the isometric drawing. So let's take a look at a few more examples with a little bit of color coding. So first thing to notice with this example is that it's actually the same object. But I've taken this object and I've rotated it, let's see, that's 270 degrees, and hopefully you can see that I've rotated it clockwise. The color coding on the top is blue, so you'll notice that we never lose sight of the top of the object, which is just an artifact of how you draw isometric drawings. But hopefully you can also see that the purple side disappears right away because we're rotating clockwise. That wall, that side of the object is pointed away from the viewer in the second projection and in the third projection. However, the red wall you can see there in the first projection is actually pointed towards the viewer, and still in the second projection when we rotate it 90 degrees, you can still see the red wall. And the green behaves in a similar manner. It moves from the right of the object to the left of the object as we rotate clockwise. This next example is all 360 degrees of rotation because it also illustrates what it's like when you lose information about an object. So you can see on the far left is what we start with. We start with a blue wall, a red wall, and a purple wall, and we rotate the object counterclockwise 90 degrees to get the second projection. So we introduce yellow as the second color, but you can still see the purple wall, and obviously you can still see the blue top. In the third projection, we lose sight of the purple, but we still see the yellow, and then we also introduce the green side of the object. Now in the final projection, you can see that this one tall tower that we've been seeing in the other three projections is no longer visible in the last projection, and that's because we rotate it counterclockwise enough that the one tall tower is hidden behind the 2 tall and 3 tall tower of the object. This is the last example that we'll take a look at. Slightly more complicated, but it also illustrates what it's like when you lose information about an object as you rotate it around. Because it's a large object, we only get 3 views again, but you can see here that we're also rotating counterclockwise. We never lose sight of the blue, but then in the first projection we have a view of the purple wall and the red wall, And as we rotate counterclockwise, we lose sight of the red wall, and then eventually the purple wall. And again, finally in that last illustration, we lose sight of the middle cube that's only one tall. And that's, again, simply because from an isometric drawing, if you only have one angle, you will start to lose information about an object. So that concludes this lesson in isometric drawings. Hopefully you should be building an intuition about what these objects look like in real life. That is, as soon as you see an isometric drawing, you can think in your head and you can rotate around that object in your head to imagine what it would look like from different angles. The homework for this video is attached, so before you move on to the next module, be sure to complete that, and I will see you in the next lesson.